All right, this is 5.7, solving systems of linear inequalities by graphing. So we are going to graph 2 or 3 inequalities, and what we're going to be looking for is the part where everything is shaded is going to be the answer in the end. You'll have a practice worksheet for this one, but we're going to start first by just checking solutions. So checking solutions mean they're going to give us a point. For instance, on number 1, they gave us 3, 5, which is x equals 3, y equals 5. And we're supposed to see if it makes both of or all of the inequalities work. So when I plug it into this first inequality, y is 5, so it's going to be 5 less than 2 times x. X is 3, so 2 times 3. So 5 is less than 6. That is true, so it checks out for this first one. For the second inequality, I get y, which is 5, is greater than or equal to 3 plus 1. So it's trying to tell me that 5 is greater than or equal to 4, which 5 is greater than or equal to 4, so it checks off both of these. So 3, 5 is a solution to this system. Is a solution. There are others, but this is one of them, so that's good. Okay, on the next one, they gave me x is negative 2, y is 0. So when I plug that in, y is 0, so that's 0 less than 2 times negative 2. I think that's trying to tell me that 0 is less than negative 4, which is not true. And right away, if it fails the first inequality, it's not a solution because it has to pass both of them. So from right there, we know that negative 2, 0 is not a solution of this system. Okay, third one, negative 1, 5. So x is negative 1, y is 5. I'm going to plug that in. It's trying to tell me that 5 is less than 5, which is not true. So this is not a solution. 5 is equal to 5, not less than. So this is not a solution. All right, graphing systems of linear inequalities. So solve the system of linear inequalities by graphing. This is what we're going to do. We're going to graph the first inequality first. So x greater than 1. X is a straight up and down line. So here's x equals 1. I'm just going to put the dots here. It would be this straight up and down line. And then this is just greater than. So this is going to be a dashed line. Make it look like this. And then it says x greater than. We're looking for greater than. So my x numbers go left to right, and the bigger x numbers are off to the right. So I'm shading in this side of my graph. So I'm going to shade this side of that line. Then we'll look at y less than or equal to 4. So y equals to 4 is the flat line, just right here. Right, flat at 4. This is less than or equal to. Since it has that or equal to, that's going to be a solid line. And then this is y less than. So I'm looking here, my y numbers go up and down, and my less, like my lower or my smaller y numbers are down. That's where the negative numbers go. So I'm going to shade down here. Maybe I should have shaded the other way. But so my solution set is the part of my graph that's shaded in both red and blue. So it's this corner over here. All of this. And it really keeps going out to the right and keeps going out down. Notice it does not include this boundary. Does not include the boundary because that is dashed. Does not include left bound. But it does include this top boundary because that was solid. Include top bound because that is solid. So every point in here is a solution to the system. Like here's the point 3, 0, and that checks out. If I plug 3, 0, this 3 is greater than 1, and the 0 is less than or equal to 4. So that satisfies our system. The point right here works. The point down here, like here is the point 1, negative 4. That's on this dashed boundary, and if I tried to plug this in, that's x equals 1, y equals negative 4, but 1 is not greater than 1, so that does not work out. Anyway, so that shaded region is the answer. Okay, let's look at y less than x plus 1. So y equals x plus 1. I have a y-intercept of 1, and it has a slope of 1, so it's going to look like this line. Less than means I'm going to do a dashed line. It's like that. And then since we're doing less than, I look at where my y-intercept is, which is right here. And my smaller y numbers are down. So we're going to shade below this line. Shade this part. All right, that's my first one. I'm going to look at my second one. So y greater than 1/2 x minus 2. So I have that minus 2 as my y-intercept, and then a slope of 1/2. So I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. And then I can keep going the other way. Just like this. This is just greater than, so it's going to be a dashed line. Okay, and then greater than means I'm trying to shade above, because this is greater than. Or you can think of it as like the big side of the arrow is open to the y, so that's greater than. So we should be shading up here. So our answer, our actual feasible set, is where these overlap. So the overlap is just in this weird, like kind of cone shaped or triangle shape in the middle. And it does not include either boundary, because both of that, like this top boundary is dashed and this boundary is dashed. So it's just the interior of those. Okay, y less than or equal to 3 is going to be a solid line because I have less than or equal to, and it's flat across at 3. And then since it's less than, or the small side of the arrow is next to the y, we're going to shade below. And then I have y greater than x plus 2. So I have my plus 2 y-intercept. My slope is 1. So I'm going to go up 1 over 1. And this is going to be a dashed line because it's just greater than. And we should be shading above because the big side is open next to the y. So a shading above right here. So I'm going to look for the plaid part where everything overlaps. And that's this corner right down here. If you have a highlighter or a different colored pen or something, it might be fun to highlight that. Notice I highlighted that top boundary because that is solid, but not this dashed boundary. I actually did that on accident, but it worked out pretty well. So nice job, Caitlin. Here we go. Okay, problem with this one is they did not give it to us in y equals mx plus b yet. I need to move the 2x over first. So this equation would actually be y, that's a positive y, is less than negative 2x minus 1. I'm going to go ahead and graph that. So I have minus 1 y-intercept and a slope of negative 2 over 1, so that's down 2 to the right 1. And I can keep going the other way. That's going to be a dashed line because it's just less than. Something like this. And since we are less than, I should be shading below on the y-axis, so it's going to be over here. All right, and for my second equation, I still need to subtract my 2x over, and that's going to leave me y. Positive y is greater than negative 2x plus 3, because that was a positive 3 right there. So I have a plus 3 y-intercept and a slope of negative 2. Okay, interesting. So these lines are parallel. This should also be dashed because it's just greater than. And then it says, since it's greater than, we should be shading above, which here's the y-intercept right here. I thought I could do this. Here's the y-intercept right here. So above are these numbers going up above, bigger on the y-axis, so it should be shaded over here. And remember, we're looking for the spot where it's overlapping, and these are not overlapping anywhere. So this would actually be a no solution. No overlap, no solution.